Hello everyone, this is Stephen from myCableEngineering. Today's tutorial is going to show you how quick and easy it is to add a cable and size it in the application. On the screen you can see details for a typical low voltage cable which I'll be using as an example. The cable supplies a fictitious compressor unit from a main distribution board and has a design current of 136 amps with a power factor of 0.86. The supply system is a 400 volt 50 Hz, 3-phase and neutral TNS system with a 23.5 Ka short circuit and earth fault level, protected with a 250 amp MCCB of an electronic LSIG trip. The cable itself will be selecting a 4-core XLPE copper cable, and we'll calculate the current capacity in accordance with BS 7671, assuming the cable is running on a ladder for 60 meters and that there's a maximum allowable voltage drop of 3%. Now that we've gone through the cable details, I'll switch to the application. I've already selected a project to work on, and to add the new cable we just click the plus button. On the left side of the input screen, we have the input form where you enter all your cable configuration and details. On the right hand side is a real-time calculation. Once we've configured the cable enough for calculations to be performed, this area will show results for current capacity, voltage drop and fault withstand. We'll be using this section to make sure that we select the correct cable and that it is neither undersized nor oversized. First thing we need to do is fill out cable descriptive fields, the cable designation, description and source. Now that we've completed the descriptive fields, we move to the system. By default, it's already set up for 400 volts and 50 Hz. I will just choose 3-phase and neutral and change the system type to TNS. For the load details, I'll change this to a general distribution circuit, add in the reference, and current and power factor. Next, we'll select the protective device by choosing an MCCB and the correct electronic trip unit. The application has automatically selected a 160 amp rating for the trip unit. Additionally, it is telling us that our maximum earth fault loop impedance is 1.31 ohms and the maximum duration is 5 seconds. Having completed the system, load and protection details, next we select our cable. We have a range of generic, standard-based and manufacturer's cables. I'm just going to select a generic XLPE armoured cable. And I'm going to ensure that it's a 4-core cable. The next step is to select a CSA. Before continuing, a question we sometimes get is why we don't automatically select the CSA. One of our core principles is that the engineer should make the final decision on which cable to use. The engineer has the electrical and project knowledge and necessary experience to be able to do this better than any software algorithm. What we do is provide an environment which empowers the engineer by doing the necessary calculations and allowing different scenarios to be evaluated easily. We tell the engineer how the cable performs, make some recommendations, but leave the final decision to the engineer. To make this process work, we need to define a cable so the application can tell us how our cable is performing. To get started in the process, I'll select 25mm squared as a good guess. Having selected the cable, I'll enter the cable length. Next, we select the cable installation and sizing standard, choosing BS7671 and ensuring that the installation method on a ladder is selected. At this stage, we could look at parallel cables, numbers of circuits running on the ladder, and temperature. We'll also notice that we now start having calculations appear. The calculation is telling us our cable is too small. It suggests a 35mm squared cable in accordance with BS7671. I'll now change the CSA to 35mm squared. The calculation updates itself and we can see that everything is okay. Moving on to voltage drop, it's already set at 3% and the calculation is telling us that the cable voltage drop is within this limit. In fact, the voltage drop is 2.23%. We'll update the fault levels to the required 23.5 kA. And the calculation result is telling us that the cable is adequate for this fault level. We've now sized the cable and we click Save Changes to add it to our project. And the first entry is the cable we've just created. If you need to edit the cable, you can click the Edit Cable button. Additionally, if we want a detailed calculation report, we can easily generate one. I will select just this cable, print only this cable, and select Calculation from the reports list and generate it. The report is generated in PDF format and shows a cable calculation in detail. If you haven't tried myCable Engineering yet, you can do so by visiting the site and registering as a user. We also have more detailed help available in the knowledge base on the site and additional videos in our YouTube channel. I hope you found the video useful and thanks for watching.